Welcome to Mr. Baker's House of Knowledge. We're here to learn how to graph lines today. It's all about learning how to graph lines, finding the slopes of lines. Slope is very, very important when you're talking about what a line looks like. It's its incline. So there's a formula for finding the slope. You won't have to know the formula, but it's really a pretty easy one. It's rise over run. Basically, the concept behind the slope is how much did it change uppy and downy versus how much did it change lefty and righty. So in finding the slope of the line, you're going to take the difference of the y-coordinates over the difference of the x-coordinates. In some textbooks, you might see a little triangle and then y and a little triangle and x, and it's not really a triangle when they're using it that way. It's the delta symbol. And that just means the change in y over the change in x. How much did you change uppy downy over how much did you change lefty righty? Rise over run. That's all the slope is. So we're going to be finding the slopes of lines. So all you need to do is you just need to identify 2 points. And when you identify 2 points, you put that information into this formula, and that will tell you the slope. The slope is very important. It is very important to be able to find the slope. Okay? So let's take a look at this blue line right here. I can pick any point that I can find anywhere on the blue line. It looks like it's already got 2 points picked for you, 2, 3, and 5, 7. So one of the points is 5, 7. One of the points is 2, 3. So one of the coordinates will be x1, y1, and the other coordinate will be x2, y2. And so if I'm putting it in the formula, it's y1 or y2. I guess I should be consistent. It's y2 minus y1 over x2 minus x1. And that's what the slope is. Slope is represented by the letter m. And the reason they use the letter m is because the Greek word for slope started with an m. I'm just kidding. I don't know if that's true or not, but it sounded pretty cool, so we'll just go with that. M represents slope. Anytime you see m in an equation, that's talking about slope. So that's going to give me negative 4 over negative 3, which will simplify to 4/3. Is it okay to leave it as 4/3? You bet your bippy it is. So that's our slope. That's how you find slope. Do y'all remember this from Algebra 1? Good. All right. So there's also some ways to talk about slope in terms of just looking at the line. If you can draw a stick figure on the line, and the stick figure has to go uphill, that's a positive slope. If you could draw a stick figure on the line, and the figure is going downhill, that's a negative slope. If you could draw a stick figure on the line, and the stick figure won't move, that is a 0 slope. If you could draw a stick figure on the line and it would fall, that is an undefined slope. Falling to your death is undefined, not moving is 0, going downhill is negative, going uphill is positive. So if I ask you to look at a line, you need to be able to tell me, oh yeah, that's a positive slope. Because when you work your answer, if you get a positive number as the answer, you'll know that at least you did something right. And you need to be able to look at a line and say, oh, that's a negative slope. So that those answers should be negative. And if you have a horizontal line, you should always say m equals 0. And if you have a vertical line, you should always say m equal undefined. Everybody okay with that? All right. This might be note card worthy right here. The slope-intercept form and the point-slope form. I'm going to give you a formula sheet at some point that'll have both of these on here. But you use this so much, it might even be worthy to put it in your memory banks. So slope-intercept form is y is equal to mx plus b. It has the y on one side and the x on the other. Oh, by the way, what do you think the y and the x might represent? What? The coordinates of the points. And the x represents the lefty-righty, and the y represents the uppy-downy. So we're going to be writing these equations. And when you solve these equations for x and y, you get a pair of numbers that would fall somewhere on that line. And there are infinitely many correct solutions to this equation. If I have y is equal to 3x plus 4, there's an infinitely many number of solutions I can put in where y and x both work for that equation. Each one of those solutions is actually a point on that line. If you find two of them, you can draw the line. And any one that you find that's a correct solution will be collinear with any other solution you find, or any other groups of solutions you find. So if you find 20 solutions, all of those solutions will be collinear with each other. That means it doesn't define a plane. That's like a tripod where all the legs are in a line and it falls over. That doesn't define a plane. It defines fall over, which is infinitely many planes. All right, so the point-slope formula is just a way of taking a single point and plugging the single point in terms of the slope. The slope-intercept formula is taking the y-intercept as the single point and then directions. So slope is always looked at as these are my traveling directions to go from one point on a line to another point on a line. You know, if I told you to stand up and face the dry erase board and walk some number of steps, and then face the back of the room and walk some number of steps, I could probably guide you out of this room. I could give you directions to the door from where you're sitting in terms of walking one direction, making a 90-degree turn, and walking another direction. That's all slope does, is it just says, hey, let's walk for a while, make a 90-degree turn, walk for a while, voila, we are still on the same line. We're just at a different place on that line. All right, so the slope is the traveling directions. The other thing, whether you have a y-intercept or whether you actually have an x and y coordinate that's not the y-intercept, that's your starting point. So when I go to graph these lines, I'll start at either the y-intercept or the coordinate, the x and y coordinate, and I'll follow the slope directions going up the top number and going over the bottom number. Rise over run. Have y'all ever heard rise over run before? Good. It's not like I just make this stuff up. It's actually math. All right. So let's graph this line. Let's just sketch a graph of these two lines. I'm going to graph line A, and I'm going to graph line B. By the way, what's the slope in line A? And how would I write 3 as a fraction? So is that positive or negative? So when I get done drawing this line, it better look like it's going uphill. What's the slope here? Negative 1/3. Do you think it's going positive or negative? Uphill or downhill? Downhill. So if I get done drawing my line and it doesn't look like it's downhill, I've done something wrong. All right. In the first problem right here, y equal 3x minus 4, that's in slope-intercept form. So this negative 4 represents the y-intercept. And since there's a minus in front of it, that y-intercept will be negative 4. So what does it mean to be a y-intercept? What does the word intercept mean? Right, it's where the line is going to cross the y-axis. Which one of these is the y-axis? The vertical, the uppy-downy one. So that's the y-axis. This is the x-axis. If y is negative 4, I go 1, 2, 3, 4 down from 0. And that's y is equal to negative 4. And then the slope is 3 over 1. So what does that mean to do? Do I go right 3 and up 1, or do I go up 3 and right 1? That's right. I go up 3 and right 1. And now I have 2 points. And since I have 2 points, I will be able to draw a straight line through them. My line needs to be black, though. So there's the graph of the line A. This is line A. And A is represented by the equation y is equal to 3x minus 4. If I find any point that's actually on that line, if I plug those numbers in, it will be true. For example, this coordinate is 1, negative 1. So if I put 1 in for x, 3 times 1 is 3, minus 4 is negative 1. And then that would equal the negative 1 in for y. So any point that you find that solves the equation will also lie on the line, and vice versa. Does that make sense? All right. So graph y minus 2 is equal to negative 3 times x minus 4. This is in point-slope form, and you're probably not as familiar with point-slope form. So point-slope form is y minus y1 is equal to m times x minus x1. Can I identify? So x and y without any subscripts represents any possible point on that line. When you start putting subscripts with the variables, then what I'm saying is I now know a very specific point on that line. So the y and the x are the ambiguous, and they stay pretty much y and x. Unless you're trying to solve for something, then you can substitute something in for them temporarily. But for the most part, when you write an equation of a line, it will have just a y and an x in it. But the y1 and the x1 are going to have numbers that we plug in because we know specifically what point we're talking about when we talk about an x1, y1. And when we're just talking about x and y, we really mean all of the points. And we can temporarily substitute any one point in there, but an x1 and a y1 will always have one specific coordinate associated with it. Does that make sense? Did that make sense? I feel like that was a lot of words. Yeah. So if you were going to put numbers in this y minus y1 equal m times x minus x1, where would you put the numbers in? Would you put it in the y and the x or the y1 and the x1? Right, the ones with subscripts is where the numbers will go. All right, so I want to fill in some numbers. So I have y minus 2 as my equation. So the y1 is going to equal what? 2. Notice that this is a minus sign and this is a minus sign. They match. So 2 and y1 are basically the same thing. If I'd had y plus 2, then y1 would have equaled a negative 2. And that's kind of confusing because the points actually end up being equal to opposite what the symbols are in front of them. But that's because it's assumed that you were subtracting. So if you don't subtract, if you actually add, then you need to take the opposite sign. What's x1 going to be? 4. So for this particular line, I'm going to start out at 4, 2. So I go over 4, 1, 2, 3, 4, and then I go up 2, 1, 2. This point lies on the line. And then the slope is negative 1/3, like we've already talked about. So that's my directions. So what do I do to do negative 1/3? Go down 1 and forward 3. So something that looks like that. And when I draw this line, it goes through those points. Okay, now since these are sketches, probably what I would want you to do is label the first point. And maybe even label the second point. So that was down 1 and over 3. So we're now at 7, 1. So I probably would want you to label your points on this. This is 0, negative 4. And then this is negative 1, negative 1. And we drew line B. So we've graphed line A and we've graphed line B, and that's a sketch. You might want to use a ruler for your sketches to make them a little bit neater. You can even put them on graph paper, and then they become very, very, very accurate sketches. Any questions about how I graphed those lines? Because you're going to have to be able to graph a line. No, Mr. Baker, I get it. Great. Then what I want you to do is I want you to next learn how to write an equation of the line. All right? So what is the equation of the line with a slope of 3 and a y-intercept of negative 5? So we've got two choices when we're talking about equations, of writing equations of lines. We can use either the y is equal to mx plus b equation, or we can use the y minus y1 is equal to m times x minus x1 equation. So in this particular case, which equation do you think we would use for A, Christian? Would we use the y equal mx plus b, having the slope and the intercept, or would we use the y minus y1 equal m times x minus x1?
Y
Right. This is the slope-intercept form. So when we have a slope and an intercept, we're going to use this form. So the first thing I'm going to do is I'm going to write y is equal to mx plus b. Does anybody have any questions why I picked the slope-intercept form for problem number A? Problem number A, problem letter A. All right, so now all I have to do is fill in what I know. What does m represent? Slope. So for m, I will replace the m with a 3. What is the y-intercept? -5. So I will replace the b with a -5. Remember, b is y-intercept. Don't ask me why they chose to use the letter b. I guess it's because if you weren't going to do x and y and you did a and b, b would be what y would be. All right, so now I just simplify this up. Y is equal to 3x minus 5. And that's an equation. Because it's got an equal sign in it, we've got our x and y variables that can be any point. That is enough information to describe that line. I now can generate the solutions of all the points that exist on that line just by knowing that equation. You know, when you were in 5th grade, you might remember making the table where you did the x, and then you did the expression, and then you found y's, and you picked some x's, and then you had some y's, and then you plotted the points, and then you could draw your line. We don't have to do that. We know how to sketch using the slope and the intercept, but that's the concept behind it. This equation gives you all the points on the line. All right, what about b? Which equation should we use for b? Anybody? Point slope, because we have a point and we have a slope. So this is very, very intuitive. If I have a slope and an intercept, I'm going to use the slope-intercept form. If I have a point and a slope, I'm going to use the point-slope form. Isn't that cool? The descriptions of the formulas actually match up with your starting information. I don't know who made up these names and everything, but they did a really good job. That doesn't always happen in math, but this guy, he was on top of it. Or girl. Could have been a girl. So, point-slope form is y minus y1 is equal to m times x minus x1. When I go to substitute in, the y and the x are going to remain y's and x's. The y1 gets the value of the y-coordinate. The x1 gets the value of the x-coordinate. And the slope gets the value, m gets the value of the slope. And then really all I have to do is simplify that up. Y minus 5 is equal to 2 times x plus 1. And that's in point-slope form. Now, could you change this to slope-intercept form? Could I make this equation right here look like this equation? Yes. If I just say write an equation, it can be in either form. But if I tell you specifically what form I need you to put it in, you need to modify it to be able to put it in that form. So in this case, if I wanted to modify this and put it in the correct form, I would distribute. That would get rid of the parentheses, and then I would add 5 to both sides, and then it would be in slope-intercept form. All right. For right now, this is good enough, though. So what I want you to do is I want you to write an equation of the line at the right. So we're going to have to do two things. We're going to have to find its slope, and then we're going to have to put it in a formula. And I actually want your answer to finally be in slope-intercept form. So go ahead and work on that right now. All right, let's take a look at how we work this problem. So the first thing I know I'm going to have to do, either formula I pick, I'm going to have to find the slope. So that's the first thing I'm going to do in working this problem. So starting point is, I guarantee if you don't know what the slope is, you need to find it. So finding a slope is pretty easy. The slope formula is equal to m is equal to y2 minus y1 over x2 minus x1. In this case, on the blue line, I have 2 points marked, 3, 5, and -2, -1. Do I have to use those points? No. You can use any known point. The problem is I'm not really sure by looking at this line if it actually crosses through a grid of points anywhere else. So those are the points I'm going to use since they're the ones they gave me. So I'll let this be my x1, y1. I'll let this be my x2, y2. And now I'm just plugging and chugging. So y2 is -1. Y1 is 5. X2 is -2. X1 is 3. So I have -1 minus 5 is -6. Over -2 minus -3 is -5. And that simplifies to a +6/5. So there's my slope. Now, since the problem gives me 2 points, I'm going to start by putting it in the point-slope formula. Remember, go with what you have. I don't really know what the y-intercept is. It looks like it might be 3/2, but I'm not sure. You can't really tell because it's not marked. And so you'd have to estimate since it's going through. So I don't want to mess with estimating and messing that up. I don't want to guess at my answer. I want the right answer. So I'm going to do y minus y1 is equal to m times x minus x1. Now you could use either point as y1 and x1 if you want. I've already got the 3 and the 5 marked, so that's the ones I'm going to use. So that's going to be y minus 5 equals 6/5 times x minus 3. All right, now here's where it gets tricky. The answer was supposed to be in what form? What form did I tell you I wanted the answer in? Slope-intercept. So we're going to have to do some conversion. If it doesn't tell you what form to put it in, if it just says write an equation like the directions say here, then you're done at this point. You don't have to change unless I tell you to. In this case, I told you to, so you need to change it. So we've got y minus 5. When I distribute that nasty old fraction, that's going to give me 6/5 x minus 18/5. All right, then I add 5 to both sides. 5 is the same thing as 25/5. So a plus 25/5 and a minus 18/5 leaves me with a plus 7/5. If I'm not sure, I can go and check it. If I put a 3 in for x, 6 times 3 is 18. 18 over 5 is 18/5. 18/5 plus 7/5 is 25/5. The y would be a 5. 5 is 25/5, so 25/5 equals 25/5. I could also check it for the other point. If I put in -2, that gives me a -12/5. A -12/5 plus 7/5 is a -5/5, which changes to -1. And the other answer over here was -1. So if I plug in both points, it works. All right, so that's your final answer. This is the equation written in slope-intercept form. Mr. Baker, that has fractions in it. I know. I don't know why you guys are putting your books up. We have an extended class period. We got like 10 more minutes. So stay with me because the bell's not getting ready to ring. Everybody okay with this one? Does anybody have any questions? All right, moving on. So writing equations of horizontal and vertical lines. Here's the problem. If you have a vertical line, then there's not going to be a slope that exists. So if there is no slope that exists, if it's undefined, then it'll just be y won't have anything to equal to. So in dealing with horizontal and vertical lines, you're going to be missing a variable. If you have a horizontal line, which this is a horizontal line, all of the points on this line that are the y-coordinate have the same value. I mean, if I'm looking here, the y is 4. 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 So on a horizontal line where the slope is 0, y equal 0 times x plus b, the answer will just be y is equal to some number. So on a horizontal line, in this case, y would equal 4. So if I wanted to tell you what the equation for this line is, it's just y is equal to 4. And if you ever see a one variable equation, just plot a bunch of that coordinate, just plot a bunch of 4s at, vertical 4s on your thing and draw your line through them. Or draw a horizontal line through 4 on the y-axis. So horizontal lines, which are the same as the x-axis, are y equals stuff. So the x-axis could also be represented as y is equal to 0. Because when y is 0, you're at all the points on the x-axis. Vertical lines are going to be x equals stuff. Since the slope is undefined, we can't make an equation. So they're always x equals stuff, and it's always x is equal to the x coordinate. And in this case, the x coordinate was 2. So notice that this line goes to the right 2 units no matter where you go on this line. So it's vertical, so it's x equal. So remember, horizontal is y equal, vertical is x equal. It's opposite of the axis. And when you have horizontal and vertical lines, when you're writing an equation, you just have to identify one coordinate, not 2. So if I ask for the horizontal line that passes through the point 1, 2, the answer to that is y equals 2. If I ask for the vertical line that passes through 1, 2, the answer to that is x equals 1. You can look at your point and just pick the coordinate you need depending on whether you're horizontal or vertical. Does that make sense? All right. Then what I want you to do is I want you to write the equation of a line that's passing through this, and then I want you to write the horizontal and vertical equations for passing through this. And since I didn't tell you what form to use, you can use any form you want for number 4. And there should be a specific form for number 5. So go ahead and work number 4. Answering this question and answering this question. If you're watching the video, this would be a great place to pause it and work the problems. Let's go ahead and see what the solutions to these two problems were. What's the first thing you need to do on number 4, Faith? Okay. Slope is y2 minus y1 over x2 minus x1. So I guess I'll do 7 minus 3 over 4 minus 3, and so that's going to equal 3 over 1, which is just 3. Everybody get 3 for the slope? So, I'm sorry, 4. Everybody get 4 for the slope? I'm glad you guys are better at this stuff than me. Most common mistake I see when people are doing slopes is they put the x's on top and the y's and get 1/4. So make sure you know that the y's go in the top. After I know that the slope is 4, I can do y minus y1 is equal to m times x minus x1. So that's y minus, I'll use 3 for the y1, and then the slope was 4. And then x minus the other 3. And then I'm done because it didn't tell me what form to leave it in. That's an equation of a line, so that's my answer. If you want to, you could go ahead and distribute it out. And if you did that, you would have y minus 3 is equal to 4x minus 12. Then you could add 3 to both sides, and y is equal to 4x plus 9. So you could have written it slope-intercept form as well. Either answer is correct. Probably, since this is easier, I would just stop here, because the more work you do, the more chance you have of making a mistake. Yes, ma'am? Yes. Well, I'm just off today, aren't I? Need more coffee. All right, and then the bottom question to me is pretty trivial. What are the equations for the horizontal and vertical lines? Horizontal is y equals negative 3. And then vertical is x equals 4. Everybody get that okay? All right, so today we've worked on figuring out how to graph a line based on whether it's in slope-intercept form or point-slope form. We've written equations for the lines, and we've talked about horizontal and vertical. Homework is here, and I will see you tomorrow.